Almost every motor on your plant, a conveyor, a fan, a pump, starts with some version of this exact circuit. Momentary start button, momentary stop button, and one trick that makes the motor stay running after you let go of the button. Let's build it. In the last video we built the simplest rung there is, push button contact, lamp coil. But think about what that means for a motor. If start were wired exactly like that button, the motor would only run while your finger is on the button. Let go, it stops. That's not how a conveyor or a fan works. You press start once, and it keeps running. So we need the circuit to remember that it was started, even after the button is released. That's what a seal in contact does. Problem: momentary button equals momentary output. Here's the build. Rung 1, a start contact in series with a motor coil, which we'll label M. Press start, power flows, M energizes, the motor starts turning. Now here's the key piece. We add a second contact, also labeled M, wired in parallel with the start contact. This is called an auxiliary contact. It's a second, additional contact tied to the exact same coil. When M energizes, this auxiliary M contact closes too, at the same instant. So now look what happens when you release the start button. The start contact opens, no more power through that path. But the parallel M contact is still closed, because the motor is still running. Power flows through the M contact instead, keeping the coil energized. The circuit is sealing itself in, hence the name, seal in. It's holding itself on using its own output. Now we need a way to stop it. We add a stop contact in series with everything else, but notice it's drawn normally closed. That means, at rest, this contact is already allowing power through. Press the stop button, and it opens, breaking the entire rung, no matter whether power was coming through the start contact or the seal in contact. Either path gets cut off, the coil de-energizes, and because the coil is now off, the auxiliary M contact opens too. The seal in releases itself. This normally closed stop button is also a safety habit worth noticing. If the wire to the stop button ever breaks, the contact fails open, same as pressing stop. The circuit fails to the safe, off state. That's intentional, and you'll see this pattern everywhere in real e-stop wiring too. Let's run the whole sequence together. Stop button, normally closed, sits first, always allowing power unless pressed. Then start, in parallel with the seal in auxiliary contact. Press start, motor runs. Let go, motor keeps running, held in by its own auxiliary contact. Press stop, everything drops out, and we're back to the beginning. 3 components, 2 buttons and 1 coil with an auxiliary contact. That's the exact backbone of motor control logic running on equipment in your plant right now: feeders, fans, pumps, conveyors. You'll find this exact structure, sometimes with extra interlocks stacked in series before the start contact, behind almost every motor control rung on the plant. Once you can trace this one, you can trace the backbone of nearly any motor circuit you'll run into. Quick recap. Start is normally open, wired in parallel with an auxiliary contact from the same coil, that's your seal in. Stop is normally closed, wired in series, breaking the whole rung when pressed. Together, momentary buttons control a motor that runs continuously until you tell it to stop. Next video, we'll look at an alternative way to do this same job, set and reset instructions, and when you'd choose one method over the other. Subscribe so you don't miss it, and if your plant uses a slightly different version of this circuit, tell me about it in the comments.